Hello everyone. Today we're going to finish up example 6 from page 16. We get to this point, we got to the R value. We found the R value, the common ratio was 1/9. So now we're going to plug all the information in now to determine what the first term is going to be. So I have the formula right here, and we're going to take that and we're going to plug our information in. And when we plug that in, we'll put 81 in for T1. You can pick either one, it doesn't make a difference. So I'm using the term 3 here. So I put in 81 for the general term. T1 is what we're solving for. R we calculated over here as R equal to 1/9. So we plug that in for R, and our value is 3 when we're using 81. So we'll simplify that. I'm going to recopy that. It's the easiest for me to do here. So I recopy that, and that gives us 81 is equal to T1. That would be 3 minus 1, which is 2. So now we're going to square the 1/9. So when we square the 1/9, we get 1 squared, which is 1, and 9 squared. We square the numerator and the denominator here, so that would give us 81. And 1 squared would give us 1, and the 2 is gone, right? And then our next step is just to recopy this, copy that, and then I multiply both sides by 81, so 81 multiplied by 81, that would give us T1, that's gone, and it would be 81 multiplied by 81, and when we take 81 and we multiply by 81, we get 6561 for T1. So the first term is 6,561. That's it. So we're finished. We have answered all the questions. It said in a geometric sequence, determine Tn. So we have our final step is again rewrite the formula. When you're looking for the general term is going to be when we have Tn in the formula and just n. So essentially you take your formula and you fill in T1, and T1 is at 6561, and your R value, of course, is the 1/9. Steal that. So I multiply by 1/9 to the n minus 1. And this is your general term. So the general term is essentially the formula that will allow you to calculate the value of any term in the sequence or series. So now the answer's finished, like I mentioned previous. This is our final answer. This is your answer for determining Tn. So a lot of steps involved. We had to do a 2x2 system with two geometric geometric sequence, but we've determined the general term can be found using this formula. Now we're going to move on to example 7. Example 7, it says if we have x plus 5, and x plus 9 as consecutive terms in a geometric sequence, determine the exact value of each term. So this is an interesting question. So if we have a geometric sequence, so it told us that means that the common ratios between consecutive terms will be equal. So therefore, we can set this up like a fraction, like a ratio, proportion here. So we can say that we have a fraction equal to a fraction. So the numerator is going to be term So we're just filling in all my information in my blanks. All right. So if we take term 2, and we divide it by term 1, that's going to be the same as taking term 3 and dividing by term 2, because we know that the common ratios are equal. if we divide them. Therefore, we can calculate what the x value is, determine the terms, and go from there. Very straightforward. So I'll recopy our equation. So the first term is given by x plus 5, and the denominator is the first term, which is x. Term 3, as you can see, is x plus 9, and the denominator is x plus 5, the second term. Now all we do is we solve for x, so we multiply. We want to get rid of the fractions here, the rational equation, so we want to multiply. Sometimes you measure it as cross multiplication. So that's going to look like the following. We have x plus 5, x plus 5, and again that's going to be in brackets. It's going to be multiplied by x plus 5 again, because we're multiplying the two denominators by the opposite, so that they'll divide out, and that's going to equal x plus 9 multiplied by x. So I've multiplied the denominator by both sides. They divide out, leaving it within the numerator on the right hand side. Multiply both sides by x plus 5, same thing happens. We get this expression. Now what we're going to do is we're going to take this expression and we're going to multiply it out. So we got to use the distributive property. X times x would give us x squared, as you guys are aware. So x times x would be x squared. 5 times x would be 5x, 5 times x would be 5x again, and 5 times 5 is 25. Again, you can just make this 10x. I know you guys are aware of that. And then x times x, again, is x squared. And 9 times x is 9x. Now we're going to solve by taking everything to one side of the equation. All right, so we'll simplify this. Then we're going to add these two together. The 5x's become 10x. All right, and then we do the same thing. And then we subtract the x squared from both sides, so they'll be eliminated. Subtract the x squared from both sides. That's good, so we don't have the quadratic to deal with. We'll take the 9x and subtract that from both sides. So 10x subtract 9x would obviously be 1x or just x. When we take the 25 to the opposite side, it's addition. So we subtract the 25 from both sides, and we are left with negative 25. So we have x is equal to negative 25. That means that the first term is going to be 25. Or sorry, negative 25. All right? And if that's x, sorry, the formatting, there we go. For x equal to 25, the next term is x plus 5, as you see above here. So to get x plus 5, that means that the next term would be negative 25 plus 5. So the next term would be negative 20. And we add 9 and we get negative 60. So that tells us that we have, oh, sorry about this. The light doesn't want to go in the right spot. So we have negative 25. We add 5 to negative 25, we get negative 20. And we add 9 to negative 25, and we get negative 16. So these are the first three terms, or the given terms, sorry, the consecutive terms in the geometric sequence. Your answer is right here, your final. Okay? All right, let's move on to example 8. So example 8 says a ball is dropped off a roof which has a height of 4 meters. After each bounce, the ball rises to 60% of its previous height. Determine the height of the ball after the 5th bounce. So we're going to write down the information we have. I'm going to go back. I'm going to grab T1. All right. T1 is equal to 4 meters. All right. The R value is the 60% of its previous height. So the R value is going to be R is equal to 60%, which is equal to 0.60 or 0.6, and we can change that into a fraction because I like to have our fractions, which would be 3/5. So our R value is 3/5. N is going to be equal to 5 because we're looking for it after the 5th bounce. So if we pick N equal to 5, that'll determine our height after the 5th bounce. Because one bounce, so you're dropping it from 4, one bounce, and so on. All right? And T to the N is what we're looking for. So we are looking for Tn. Oh, sorry about that. Tn is what's in question. So we go to our formula, and we are going to grab our formula. I'm just going to scroll up to grab our formula. There's our formula. T to the N is equal to T1 multiplied by R to the N minus 1. Let's fill in the information we have. So Tn is what we're looking for. So we're looking at T5, we can call it if we wish. The first term was the initial 4 meters. The R value in this case is going to be 3. Oh, sorry. I'm going to take my brackets, which are important. All right, and that's going to have a fraction in the brackets, and that's all going to be raised to the power of 5 minus 1. And it's 60%, which is the same as 3/5. All right, now we're going to solve for the 5th bounce. So 5 minus 1 is 4. Now we got to take the numerator and the denominator of our R value, 3/5, and raise that to the power of 4. So that becomes 3 to the power of 4. Oh, my apologies. So it becomes 3 to the power of 4 and 5 to the power of 4. And then you multiply the whole thing by 4 when you're finished. So the 5th term is going to equal 4. 3 raised to the power of 4 is 81. 5 raised to the power of 4 is 5 times 5 is 25 times 5 is 125 times 5 again is 625. So our final step is to multiply the numerator by 4. So that means the 5th term will be 4 multiplied by 81, which is 324. That's multiplied by the 4, so the 4 is gone, which we know is equal to, we punch that in our calculator, 0.154, 84 meters, which, if you want to get an idea what that is approximately 52 centimeters. So that means if you are on a roof and you drop a ball at a height of 4 meters, and after each bounce it rises to 60% of its previous height, that means after the 5th bounce it will rise up to just over half a meter, 52 centimeters. All right, we'll finish off the section 1.3 in the next video with examples 9 and 10. Thanks for watching, and I hope you're enjoying the videos. Just another resource to help us out. Thank you, everyone, and we'll see you again in the next video.